Okay, Bismillahirrahmanirrahim. This is another interesting topic which is very important for you. Class 9 Physics chapter number 7, Archimedes principle. Okay, you may also pronounce it Archimedes principle or Archimedes principle. The statement of this principle is the buoyant force acting on an object fully or partially submerged in a fluid is equal to the weight of the fluid displaced by the object. What does it mean? I will explain these all things here in detail. Let's suppose this is an object and this object this object is submerged into this container having water or any fluid. So when this object is submerged here into this container, it will make space for itself and will remove the water or the fluid. So the fluid will here the fluid level will be increasing. Like let's suppose this is level 1, and now when we submerge this object into this water, so the water level will be increased, and this is level 2. When the water level increase, so the water will be fall down into the next container here. So here we will collect the water which is falling due to the sinking of this object. Okay, so Archimedes says that the buoyant force here on this object, and you know the buoyant force, the force exerted by the fluid which is displaced by the object. So the buoyant force will be always equal to the weight of the displaced water or fluid. Here the weight of the fluid will be providing that buoyant force. So the buoyant force here will be equal to the weight of the displaced fluid. Weight of displaced fluid. Now the more water or fluid is displaced, the more will be the buoyant force, and the lesser the fluid weight, the lesser will be the buoyant force on the object from the downside to the upward side. So the magnitude of the buoyant force will be equal to the weight of the displaced water. Now this buoyant force here will give a thrust to the object. So the net force here on the object will be, the net force is equals to the buoyant force minus weight of the object. Like this object will have some mass and will have some weight. So the weight will be equal to the mass mg, mass of the object and gravitational acceleration. So this weight of the object is also collected with the buoyant force. So the buoyant force and the object both are moving upward. So if we remove the weight of the object or subtract the weight of the object from the buoyant force, then the remaining force will be called the net force. So WO is equal to MOG. Here the buoyant force, from the buoyant force the weight of the object will be subtracted, so we will get the net force on the object. Now as we know that the buoyant force FB is equals to the weight of the fluid displaced, because buoyant force is always provided by the weight of the displaced fluid. So I can write WF instead of the buoyant force, WF minus WO. Now as you people know very well that W is equals to mg, so WF will be equal to mfg and WO will be equals to MOG. So F net is equals to, instead of this W, I'll put the mass of the object, mass of the fluid, and gravitational acceleration minus mass of the object and gravitational acceleration. Now, let's suppose this is equation 1. You know the density is also equals to m over v. From the density equation, we will have the mass value will be rho v. So by putting this value of mass in the equation 1, put in equation 1. So in equation 1, instead of mass, I will put the value rho v. So F net is equals to rho F V F G minus rho O V O and G. Now you can see that here the G is common in both of them. So F net is equals to rho F V F minus rho O V O into G. Let's suppose that is our next equation number 2. So the net force in term of weight is like this one. The net force in term of mass and gravitational acceleration is this one, and the net force in term of volume, density, and gravitational acceleration is this one. Now we can form two relations. Number one, relationship between weight of the object and buoyant force. Relationship between the weight of the object and, I have written here, object and buoyant force. In term of masses. In term of masses. So the ratio of the weight of the object with the buoyant force will be equals to the weight formula is mg, so this is mog, and you know that the buoyant force is due to the weight of the fluid. So instead of fb, I can write the wf and mog, and instead of this wf, I will put mfg. So g will be cancelled with g, and this relation will become wo divided by fb is equals to mo divided by mf. So that is relation or ratio of the weight of the object with to the buoyant force will be equals to mass of the object and mass of the fluid, which is displaced by the object. So you can write this mb or mf. Both of the things are both of the things are correct. Now the other relation that you can make from this, that is number 2, relationship of weight of the object wo of the object wo to the buoyant force in term of densities. So in term of densities, we can write the equation or the relation or the ratio wo divided by fb is equals to, again this is mog and this is due to the weight of the fluid, so I can write it mog divided by mfg. So g and g will be cancelled with each other, so this will become mo divided by mf. Now this is already exist here, so instead of w I will put the value of the mo and the mf in term of the density, like this one, in term of the density. So as we know that m rho is equals to m over v, so m will be equal to rho v, so I will put this in this equation or in this relationship. Okay, so wo divided by fb is equals to, instead of mo I will put this rho v, so rho ov divided by rho fv. Here the volume will be cancelled with the volume, and it will give us the final relationship of the weight of the object with respect to the buoyant force in term of the densities, in term of the densities. So this is another third equation for the Archimedes principle. Due to Archimedes principle, we can say that the buoyant force on an object will be always equals to the weight of the displaced water. That is a very simple principle. The more water or liquid is displaced by the object, the more will be the weight of the fluid and the more will be the buoyant force on that object. Okay, so if you have any question you can ask me. Clear?